In the next problem, here we have an application problem. It says a taxi company charges a fee for waiting at a rate of 75 cents per minute or any fraction thereof. Draw a graph to represent this situation. So we're going to draw a graph. Let's make a table. So what I'm going to put here is I'm going to compare my time to my charge. And I think I'll put in some decimals here so we can understand. I'm going to count by half minute. So I'm going to go 1/2 minute, 1 minute, 1.5 minute, 2 minutes, 2.5 minutes, 3 minutes. I think I get the idea after that. So we're going to charge 75 cents for every minute. So if you're only there for a half a minute, you're still going to be charged 75 minutes. If you're there for a minute, you're going to be charged 75 cents. After a minute passes, it goes up another 75 cents, so it'll be $1.50. And then 2 minutes is going to be $1.50. And then we add on another one. I'm going to go $2.25. And that'll be $2.25 for 3 minutes. So I think what I'll do, my time is my independent variable. So I'm going to put time here in the bottom. So I'm going to go 0. I think I'm going to skip a line just so you can see it. So 1, 2, 3 minutes. And I'll do the same thing going up. So here's 75 cents. And then $1.50 and $2.25. And I could keep on going up and up if I wanted to. So we know up to 1 minute, you're going to be charged 75 cents. So from 0 minutes, not 0, but all the way up to 0. So maybe I should put an open circle on 0 also, because you're not going to be charged for 0 minutes. But 1 second after that, you're going to be charged 75 cents. And then I fill that in because you can be charged 75 cents for 1 minute. So after 1 minute, it's going to jump up to $1.50 all the way up to 2 minutes. After 2 minutes, it's going to jump to $2.25. And we could go like that forever. Here is our step function. I'll put one more just so you can see it goes on forever. Now we have things that are not step functions. They're just like two lines, both on the same grid. Notice what happens here. My function changes at 0. When you're less than 0, I'm going to follow this rule. When I'm greater than or equal to 0, I'm going to follow the second rule. So let's make a table. That's probably the easiest thing to do. I want numbers that are less than 0. So I'm going to put 0 in for x for my first rule, but it actually can't be that because it doesn't include this point. We'll start here. Then we'll go -1, -2, -3, so you can see what's going on, because I'm going less than 0. I want numbers less than 0. So what is the opposite of 0? Well, the opposite of 0 is 0. And kind of like your step function, you're not including this point in your graph. So I'm going to put an open circle here on 0. That's kind of hard to see, so I'm going to go a little bit up. Okay, what's the opposite of -1? Well, that's 1. The opposite of -2 is 2. The opposite of -3 is 3. So I'm going to plot those points. So at -1, I'm going to be up 1. At -2, I'm going to be up 2. At -3, I'm going to be up 3. Do you see the pattern here? I'm going to draw my ray because it's not the whole line. Because at 0, it changes again. Now I'm going to do my second line. I'm going to use a different color here so you can see it. Only this time I want it to be greater than or equal to 0. So I'm going to have x and y. And I'm going to put in 0, 1, 2, and 3 because it's going up, because it's greater than 0. Now I'm going to plug those numbers in. I'm going to put in 0 into my second rule. Well, the opposite of 0 is 0. 0 plus 2 is 2. Then I'll do my next one. The opposite of 1 is -1. Negative 1 plus 2 is a positive 1. And then the opposite of negative 2 is, or the opposite of 2 is negative 2. Negative 2 plus 2 is 0. And then I'll do 3. The opposite of 3 is negative 3 plus 2 is negative 1. Now let's plot those points. So I'm at 0, I'm up at 2. When I'm at 1, I'm up at 1. When I'm at 2, I'm up at 0. When I'm at 3, I forgot my negative sign there, didn't I? There we go. At 3 should be negative 1. So at 3, I'm at negative 1 because negative 3 plus 2 is negative 1. So my line looks like this. Now, what are the domain and range? Well, notice no matter what number I pick for x, my domain is going to be all real numbers. My range, well, I could have anything for the range, couldn't I? Because I got double points here for y, but I could any y to the right is going to be negative. If I keep on going to the left, it's going to be positive. So that's going to be all real numbers. And I just realized on the very first example, that was the domain and range question. I never did that. So let's go back here and let's look at the domain and range from example 1. Once again, kind of like the previous problem, no matter what value of x I pick, I'm going to have an answer. So my domain is going to be all real numbers. My range is going to be a little bit different on this one because my range doesn't include any decimals, does it? It's like negative 5, negative 4, negative 3, negative 2, negative 1, all the way up to 0, and I could keep on going. So I'm going to say my range are going to be integers. So it can be any number, positive or negative, but no decimals. So like negative 1, negative 2, in fact, you could in set notation that we dot, 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 negative 3, negative 2, negative 1, 0. I ran out of room here. 1, 2, 3, dot, dot, dot. Keeps on going on forever and ever. That's how we would do that problem.